We're going to go ahead and look at solving quadratic equations. One of the ways in which you can solve them is by graphing. Then later in this chapter, we'll look at solving by factoring and solving with completing the square and solving by the quadratic formula. But today, it's solving by graphing. So to solve by graphing, for the most part, you're looking for the roots of that equation. Now, if you're looking for the roots and you're looking at it graphically, that's looking at the zeros. That's where your y value is 0. That's where you're crossing the x-axis. Your y value is 0. That means you're not up and down. So that's why it's called zeros. However, there's other terms that also refer to doing the exact same thing. One of them is mentioned as above as your roots. But your zeros, where you're crossing the x-axis, is also referred to as your x-intercepts. You could also look at it as solutions. So for the most part, there's small, minute details that differ between these words, but think of it in general, whether you're looking for zeros, x-intercepts, roots, or solutions, all meaning the exact same thing. So to solve this one by graphing, for the most part, you want to go ahead and graph the equivalent function. Once again, you'd want to do negative b over 2a to find the x-coordinate of your vertex, and that's going to be helpful. And then you'd want to, once again, just like in the earlier video, choose 3 numbers on each side, plug it into your y equals, go second window to your table set, start it at negative 2, and then you could go ahead and plot your points. And then when you plot your points, you would get this graph over here. Now, there's 2 ways to identify your zeros or your answers, and that's when your y value is 0. And well, we have that right here, so we know one answer is at -1 and one answer is at 4. We can also see that it crosses at a height of 0 here, your x-axis right at 4, and also here at -1. That's where you can see it graphically. So since it crosses the x-axis twice, we have 2 answers, and we want to write down our 2 answers of where it crosses. Now, whether you get that from the table or whether you get that from your graph does not make a difference. So if we want to solve this one by graphing, first of all, you got to get 0 on one side by itself. So I'm going to add 4 to both sides, and we get this. Now, to solve this one by graphing, we can graph the equivalent function of x squared minus 4x plus 4, put that in your y equals, then you'd want to do negative b over 2a, which is 2, and then choose 3 numbers on each side. Do your table set, start it at -1, plot it, and we get this. Now, we know we only have one answer here because we only have one output where the y value is 0. When you look at your graph, you can see that you only have one spot where you're touching the axes. So that's what we would write down. We would write down that our answer is 2, because that's the x-coordinate of where it crosses, or you can see that here in your table. So we're going to go ahead and solve this one by graphing. First of all, it's a word problem, so we need to go ahead and put it into equations. We're looking for 2 numbers whose sum is 4 and whose product is 5. We're looking for 2 numbers, so I'm going to let x be the first number, y being the second number. So now I'm going to write out one equation for when it's the 2 numbers whose sum is 4. Well, sum is your answer after you add. So I got to take my 2 answers of x and y and add them together to get 4. Well, then I'm going to write my second equation for whose product is 5. Product is your answer after you multiply. So I got to multiply my 2 numbers together to get 5. So now all I'm going to do is try to come up with one equation instead of 2. So I'm going to solve the top one. I chose to solve it for y. It would not make a difference. So now all I'm going to do is take this right here and plug it in right here. If I do that, I get this. Now, to solve by graphing, once again, I'd want to have everything on one side set equal to 0. So first of all, I'm going to get rid of the parentheses. Then I'd have to bring the 5 over by subtracting 5. And then I'd have my nice normal quadratic function that I could go ahead and graph. So I would put this into my graphing calculator, negative x squared plus 4x minus 5. Do that negative b over 2a, choose 3 numbers on each side of that. So once again, this one starts at negative 1. Now I'm going to go ahead and get my y values. And in this case, you'll notice when you plot these that your parabola is always below the x-axis. You'll notice you're never equal to 0 here. So we actually have no solution because we don't cross the x-axis. Now, if we did cross the x-axis, or see that we got 0 out here in our table for the y values, then you would have those as being your answers. Now, solving by graphing is nice. It gives you a nice visual of what's going on and where it's graphing, but solving by graphing is not always precise. On our examples we tried here earlier, yes, they all did work out nice, which is it's okay. But sometimes they don't work out nice. If you were to graph this one here and do negative b over 2a, your table would look like this. Now, we know we're going to have an answer when we plot this. We're going to have an answer between 0 and 1. We know we're going to have an answer between 0 and 1 because at 0 you're above the x-axis. At 1 you're below the x-axis. And you can also see that over here, that we're going to cross in between 0 and 1. You can see at 0 you're above, at 1 you're below, so we got to somehow cross in between. And you can see that when we switch from positive to negative here with our y values. You can also see in your tables from when you're below at 5 to being above at 6, where you'd have to have another answer. And we can see that over here on our graph. So we have our answers for estimating being between 0 and 1. You can get that from the table or the graph, and also between 5 and 6. So write them out like that.